right, bro. So yeah, yeah. If you could take a look at the problem and then just let me know when you're ready to start. I guess I already started recording, so.
Oh, good.
Yeah. So
All right, so I read the question.
yeah, yeah. Yeah. So it's yeah. It's just basically getting the range between those values, and then if you look at like example one, all the values in the BST like that are within that range are added together, and then
Mhm. They say no values or will be repeated.
yeah,
Okay.
yeah.
But let me format this correctly. So first thing I would do would be having to knowing how to iterate between every node. So assuming if this is my tree, hold up, I have to make these numbers bigger. 10, 18, and then over here, and then 1, 6, 13, 21.
Yeah.
So assuming something like this is my tree and I have to do 5 and 18, I would only have to go down 1 all the way to the right. So there's no need to go through every single node. So I'll probably do some form of traversal where there's a stop once I get a certain key, which will break um, the loop, so it doesn't go more to the left. Because if when I check for L, I'll have to stop going left, and when I check for right, I'll have to stop going right to get out of the range.
Yeah.
So something like 5 for 18, I'll have to go boom, 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 boom. Okay, so I'm gonna do, how do I do post-iterative traversal? I'll have to start. Um, well,
Yeah. Yeah. So like the base case would be first.
base case, in case anything gets put in here, that should, this return, so I'm gonna assume it returns 0. Assume if empty. Actually, no, I'm gonna make it return -1. So that way the user knows that it was empty. Wait, actually no, 0 makes more sense. Oh wait, no, this is a range. I'm not asking for a number of something. So
Yeah. So like yeah. So basically, like you kind of like have to traverse the whole tree and um just find the numbers that are between that range. So like so even if like let's say your range is like from 4 to like 13.
mhm.
Oh, that's weird. Yeah, you would wait, let me think about this.
This is basically what I'm writing right here is that if L, let's say if someone puts L for 5 and R for 5, because 5 can be, it says that in the question it says there's no guaranteed values. That doesn't mean that they won't put the same left or right. So if the one of the base cases has to check if L and right are equal, and if they are, that means that you don't have to traverse anything and you just return um that value. So and I'm gonna assume that that is data in this. Wait, is there a class here they provide? So I'm just gonna assume that it's the basic class that we had. And then if root is empty, yeah, okay, this is fine. This should be the. I think these are the two cases where you're not gonna have to traverse anything to find an answer.
But then if the range are equal, wouldn't you want to like find the nodes like it's not necessarily the root node, or are you doing a recursive function to for this?
Oh no, you're right. That's a good point. That's a good point.
Yeah.
So then I'm just gonna.
You could also make another function if you want, like which traverses it, and this one just basically has the sum variable. So that would be another way.
Wait,
Like,
no, I thought I could get around that. Instead of returning root data, I could just return either L or R. Yeah, and that way I don't have to traverse anything. Because in that case, if I know that I'm gonna return anything from, wait, can I assume?
well, yeah, I mean, you can assume in this one because if the range is
Can I assume that the L and R are going to be in the data set? Because let's say that there's two nodes and it's 1 and 3, but my L is 4 and my R is 5. Like those were never triggered. But in the examples, like I'm assuming that they'll always be present. Like if they get if someone puts in L or R, then I can assume that they're in the tree.
not necessarily. There's if you look at them, one of them has the range of 7 and 15. Oh, are they actually?
Yeah, they're both in.
The binary search tree is guaranteed to have unique
I'm
values.
gonna assume.
But if you look at the second, oh damn, it does have it.
I'm gonna assume that they're in the tree based off the examples. Because they could have given like if one of the examples would have been different, then that would have been something different. I'm just gonna assume and like go
Yeah,
on with that.
yeah, we could assume that if anything, and then
Are values in the tree? Okay. So I got rid of that case. Assume the tree is empty. Returns 0. Excuse me. So I'm gonna traverse. I need to. Oh, sorry. I need to draw real quick. Let me get a piece of paper.
bro, I want to say we started around like 5:35, so
Yeah.
we'll just cut off once we get like the.
So wait, am I thinking the wrong thing? Okay, so first thing I'm gonna do is I'm gonna make a pointer. Delete these. we're gonna make node pointer. Make this equal to node. And I'm gonna have to work with a stacker queue here. So I'm gonna write on my while loop.
Yeah.
Out which one I should use.
Yes.
So I'm gonna use this table for reference. I have 10, 5, 18, 1, 6, 13, 21. I'm gonna go into the root pointer. So this should be equal to root pointer. There's no need for it to be null because I'm always gonna have to start pointing at the top. And if it's null, this would have broken off already, so it doesn't really matter to make this null.
Yeah. So yeah, so you can declare your stacker queue, I guess, and then you can push the temp pointer so that you have it there, and then when it goes into your while loop, I guess it will go through, I guess, because it isn't empty. So
Point. So if I put in these things into a stack, so let me do 5 and 13 as an example. And then let me do 13 and 21 as an example. So that way I have a base case. What happens if I only have to go on one side of the tree? So if for me to get to the 5th node right now, if this were a stack, I would push in 10, then change. I think a big thing here is going to be if L and R, if whatever I'm pointing to, the data with there is greater than or equal to L, and less than or equal to R, damn, doing this in Google Doc is terrible. My God. Then I will add some pointer data. So I'm gonna make a sum variable over here.
Yeah.
Which is what I'm gonna return at the end of this function. And then sum will be, I like to write my things out. I don't believe in that plus equal sign. Yeah, that should work. Oh wait, let me make sure these calculations. So 10 pointer data. So now since I have how to add into the sum. I guess it's
half the living room. I think.
Really? Keep going, baby.
all right. What about your while queue? Like I mean, your while loop or like the while the statement you still haven't like.
Yeah, I'm still waiting on this. This statement is gonna be if queue is empty or stack is empty. So I'm just leaving it there blank until I decide which one.
All right. Yeah.
Because I don't really think it matters what I hold up. Actually, it shouldn't matter depending on if I'm trying to avoid traversing. Because the easy way to solve this problem is just traversing every node and checking, and then we go on with our life. I'm trying to make it so that I need a the 10 pointer cannot change. Adding this is going to be at the end. The 10 pointer I got it. So if 10 pointer is less, oh damn, I did awesome. Is less than or equal to R. Wait, no, I did the same thing again. Trying to figure out how to traverse the nodes. Let me just do it with a stack so I can get it over with. Because if I don't make a choice, then I'm gonna make a choice. Stack. I'm gonna just name this range stack. Hmm. Okay, so making a stack, I'm gonna say if, so when the, actually for pre-order, velocity, when the stack is empty, the range stack, yeah, I'm not gonna use an equal sign for clarity, make it easy to read. So then, 10 pointer, it's already pointing to the root. I have to push this.
Yeah, you have to push the initial one.
Yeah, I have to push this. But no, I'm not going anywhere.
Yeah.
I can push root or 10 pointer. I don't really think this point doesn't really matter since I initialize it to root, but then right here it's gonna change immediately. To the top. Yeah. Range stack. Then I'm gonna do anything there. Remove the stack. So now it's empty. So now I have some form of exit condition, but I'm still pointing in the middle. So I can still add this data. So 10 pointer um I like the sound of that. So if this has right node, let me just make sure it's not null. Then I will push push 10 pointer right, and then let me do the same thing for the left. So now I have decided what to add. Only thing now I have to check for the conditions. So considering this is checking if the right pointer, I'll make it if 10 pointer equals null and 10 pointer data is is or equal to R. There we go.
Yeah. So yeah, if it's in the range, you would still check the right value.
Let's say that again.
Yeah, if you're like in the range, you would still check the right or left values. Like if you get the like the root node and it's between those values, then you don't like have to you have to check on both of them, I guess. So that's correct.
Okay, well, right now I'm gonna test this on paper. Wait, I have to return. Where's my? Okay, this is there. This is there. All right, I'm gonna just hope that. I'm not gonna hope, but return some. This is. Oh, it's still in the while loop, so I have to return some down here. So. All right, so I'm just gonna do this on my paper to see if it'll work. Okay, so oh damn, I erased this. So I'm gonna use 10, 5, and 18, 1, 6, 13, and 21 as like my practice example. So let's say I want to know the data between 5 and 13. So I should be adding 5 plus 6 plus 10 plus 13. It's 11 plus 10. I should get 34.
Yeah.
34. There we go. Okay, so the intro in this method, the root pointer will be pointing to 10. L has a value of 5. R has a value of 13. Okay, they're not equal, so we don't have to return them. It's not null, so this is irrelevant. Okay, we make the stack. All right, so right now we have 10 into the stack. We have 10 in the stack. 10 pointer is now pointing to the top of the stack, so it's not pointing to 10. And we pop it out of the stack. So now 10's not in the stack, but 10 pointer is still pointing to it. So if 10 pointer data is greater than 5 and less than R, I mean greater than L, less than R, it goes in here. So sum right now has 10. If 10 pointer right does not equal null pointer, and this has to check for the right node and the left node for their data, not the current node that we're on. So if 10 pointer is not null, okay, the right's not null, and the data in there is less than R, push. It's not. 18 is greater. All right, so now I realize that since 18 is not in the range, I cannot get to 13 because I push it right here. So I think that I will have to go through 18 regardless. And this checkpoint, I mean, not checkpoint, but this condition is not the right way to go about this.
Okay, so yeah. So I was looking at that too. Yeah, I was like thinking about how maybe like if you go from 10 to 18 to now you have to check to left sub node of 18. So I think like that maybe a better way would be to
One thing though is that if a value, wait, would it 21? Nah, because I was thinking that maybe a value would only have to go, like let's say we were looking for our cap was 13 and then we went from 10 to 18. It would only be one time that we go over 13, and maybe I could do like some Boolean cheese. Like I think that's probably the best thing I probably that's the best thing I'm good at, making random Booleans to make my code work. Um, but no, I don't think that'll work. I think I'm gonna have to traverse the entire tree.
yeah.
I think once let me just delete this then, so that I can, because right now what this is doing is I traverse the entire tree, and if that node meets a condition, I add it to right here. So I think all I have to be looking for is,
So I think like it would be better if you what's it called? You compare the value of the root node. So like when you're checking for 10, instead of checking for the left sub, like the let's say like the next node to the left, because it might be greater than the actual range. I, instead, just since 10 isn't bigger than the range, then you know that you can't go to the left one. So like let's say the range was like the max range was like 9 and you have 10, then that means every other value is going to be bigger than 10. So you can't do that one. So let's say like if you were to go to that one, I would say like that case, you would have to maybe compare it to the root node instead of comparing it to the right or left like you did. So you get what I
but the
mean?
thing,
Because when you get to 18, yeah, let's say you get to 18, right? Then, hmm,
the thing is that you need this condition because if you need to check if there's a node, I'm just here checking if there's a node there so I can add into the stack so I can have it for later. I
yeah,
think the issue is that in traversing, um, once you hit the damn, interesting. I think having the nodes be on two different levels, like the ranges, is because what I did before would work if let's say you could only ask the range if they were on the same level, right? Because then
yeah,
I know that eventually, oh, I would hit 18 specifically. But since I'm on different levels, then I think I have to traverse the entire tree.
yeah, you do. Yeah.
Off the top of my head, like there is definitely there has to be some cutoff point up here, but like this code would work. It would solve the problem.
Yeah,
Um,
this one would. It's just it would just push extra elements to the stack, but it shouldn't make a difference in the code, I guess.
I might have to go. I might have to. I think it's a very interesting question because no, the thing is like I think obviously traversing every node is a waste of time. But I think
Yeah,
the only way to not traverse every node is that if you hit the node, like let's say right here, right? Like let's say if my range happens to be 5 to 13, if when I'm traversing, I hit 5, then I'm like, okay, I never have to go left again. So probably one of these, like the right, would only have to be compared to, hold on, wait, let me do the left one first. If I think one thing I might do here is I might make this, let's say, hold up, an else if statement, and then make an if statement to check if the current node, wait, I could do that earlier. If the data in left, if the 10 pointer left data is equal to L, then range stack. I think I know what I'm trying to do here, but I'm basically just trying the same code twice. Basically, what I'm saying here is that if we have to keep traversing, like we know that chances are we're gonna have to traverse whether we start to the left or to the right. Like let's say if it's 5 to 6, like okay, I go here and then I have to go right and left. Like you have to make those choices. That's on the carpet. Wait, the dog here? That came out. That's disgusting. Thank God you bought that, bro. My girlfriend right now is vacuuming the carpet, and that shit's disgusting. Oh my God, Jesus.
Is your floor carpet?
Yeah, majority apartment at Oxford's
Yeah.
carpet, disgusting. Yeah, I'm not gonna make this an also statement for right now because I think I know what I was trying to say there, but I don't really think it's. How long have we been recording?
For about 20, 30 minutes now.
Yeah.
So we have like,
In 10 more minutes, we'll just cut it off then, because.
yeah. So yeah, your solution will work. It's just not time efficient in a way. So that's like the only thing I would say. I forgot about
Pull
I
up
forgot.
the. Do you remember like what were the conditions for it though? I know I just have it has to be when I push the node that there has to be because the thing is I don't understand how do I make if I use this key because if I had to get 13 then I cannot put like if they're on different levels then I cannot use L and R as like my boundaries because then I'll never get to one of them.
Well, the thing is, this isn't like about the levels. It's more like, yeah, just like I guess the the nodes can be in any way or like any orientation, but it will be always a BST. So I guess like one of the conditions for the solution was that if you go to this node right here, let's say 18, right? Since we know that this value is bigger than the range, we don't have to travel to the left subtree, or I mean to the right subtree, which would contain 21.
Yeah.
We would have to go to the 13. Same thing with 5. So let's say like the range was like was 5, like in this case. Now since we know that binary search tree only has one unique value, anything less than 5 would be not in the range. So we would have to check every right subnode, which would be like 6, and then whatever continues. You understand?
Yeah.
Yeah. So that's, yeah. So I guess like what you were doing was kind of correct, but instead you when you had the node, when you had like the root node as the temporary, you were comparing the value of the next node. And I think it's better if you compare it with the temp value that you have at the moment. So, because now you know that if that temp value is bigger than the range or less than the range, you don't have to go to one path and you just have to focus on the other path.
Oh, I get so check the current node, and if
Yeah.
the node is above R, then okay, I gotta go left. And
Yeah. Yeah.
Because if you're right, if I check the next node, then and if that's bigger, then I can't go anywhere. But if I check the current node and I'm bigger, I can like okay, I know where I gotta go
Yeah.
right now. That makes a lot of sense. So then in that case, this would be it would be what
Yeah. So yeah, your solution does work like currently, but this would just make it efficient so that you don't have to check every.
to make it efficient, I would have to add the item pointed data less than wait no, because then I wouldn't put it into it. It would be how's the code for that?
What happened?
How's the code for that? For 10.
Yeah, so you would be like temp and temp pointer is let's see.
I think it has to. I think an if and else statement, and then check first if it's above or below the range, and
Mhm.
then go through there. Because I think
Yeah,
what I'm realizing right now is that if you try to do an if statement with a bunch of conditions, then it's just maybe there's some set of conditions that work, but I think it's a lot simpler just doing it one at a
yeah.
time. All right, damn, killed 40 minutes. Let's go. Good stuff. What do we
Oh,
do?
hold on. So you want to end it right there with your solution?
Yeah.
Yeah. So yeah, I have to give you like a little bit of feedback. So yeah, I think your code does work. It would work. If we were to put in an IDE. I'm not sure about this. The first condition, I technically, if we have a range, those numbers don't have to be specifically there. So, but that's just an extra condition, which I guess like will give us like the the value right away. So it is efficient in that way. Um, yeah, and then if the root node, yeah, so that's good. Yeah, so yeah, yeah, I think the implementation was good. It's just that with that one we had a little bit trouble just because like I guess like I didn't explain like correctly the first time, so that's on me for
We
but
go.
yeah, your solution will work. Just if you were to implement those other like um conditions, like whether we check if that specific node that we're on right now is bigger or less in the range, then it would make it more efficient just by that. So
Mhm.
I guess that's it.
Um,